Hello friends, a very warm welcome to another discussion on a topic to enable us prepare for the examination called CSAT. Today's topic is calendars, and of late it has been found that around 2 to 3 questions have appeared in the previous year's CSAT papers. There are a lot of varieties of questions actually. So let us have a look at the very basics and then take off from there to another level of difficulty. Alright, so as we know, there are 12 months in a calendar year, starting from January, February, March, April, May, June, July, August, September, October, November, and December, as we all know. Now, there are two kinds of years that we are going to talk about. One is an ordinary year and the other is a leap year. Now, what is the difference between these two kinds of years? An ordinary year will consist of 365 days, whereas a leap year will consist of 366 days. Now, in an ordinary year, there are 365 days, and basically it is the month of February where the difference lies. In a leap year, there are 366 days. Now, you saw that. Now, in the month of February, we know that there are 28 days. Now, when we talk about a leap year, it has 366 days, where the month of February has 29 days, 1 day extra than the ordinary year. So, in a leap year, there are 29 days in the month of February as compared to 28 days in the month of February in an ordinary year. So, we can conclude that in an ordinary year, there are 52 weeks and 1 odd day. Now, what does that mean? Now, if you just divide 365 by 7, because there are 7 days in a week, goes by 7 5s are 35, 15 7 2s are 14, remainder is 1. This remainder is called odd days or extra days. So in an ordinary year, there are complete 52 weeks, each consisting of 7 days plus 1 extra day, which is called an odd day. Now similarly, in a leap year, there are 52 weeks and 2 odd days. Well, when we divided 365 by 7, we found that 365 goes by 7 by 52 and 1 is the remainder. Now if 366 is divided by 7, we will get 52 as the quotient and 2 as the remainder. So in a leap year, there are 52 weeks and 2 extra days, which are called odd days. Now we talk about 2 more types of years here. One is a non-century year and the other is a century year. Now what is a century year? Century year is a year which is divisible by 100. Year 1700, 1800, 1900, 2000, 2100 or even 500, 600, all these are century years. Non-century year, obviously those years which are not divisible by 100, which do not have the last 2 digits as 2 zeros, like 2021, like 1947, 1857, 678, all these are non-century years. Now the point is, how do you find out that the given year is a leap year? Well, if the given year is a non-century year and if it needs to become a leap year, then it must be divisible by 4. So a non-century year is a leap year if the year is divisible by 4. Now what is the divisibility rule for 4? Any number, let us say the number is ABCD. Now you want to check whether this number ABCD is divisible by 4 or not. Now look at the last 2 digits, C and D. The number which is formed by these 2 digits, let us say C and D together, if that number is divisible by 4, then the complete number ABCD will be divisible by 4. Like we have 1324. Now 24 is a number which is formed by the last 2 digits, 2 and 4. And 24 is divisible by 4. Hence, 1324 is divisible by 4. Now you have another number, 1950. Now the last 2 digits, 5 and 0, they form a number that is 50. Now as 50 is not divisible by 4, hence the complete number 1950 is not divisible by 4. So the number formed by the last 2 digits of the bigger number, if these last 2 digits form a number which is divisible by 4, then the complete number, the bigger number, will be divisible by 4. So as you can see here, this is the calendar for the year 2020. So 2020 was a leap year because 29th February occurred in this year. there were 366 days. And 20 here is a number which is divisible by 4. Hence, 2020 was a year which was a leap year. So a century year is a leap year if the year is divisible by 400. Till now, there have been 5 century years, and which have been those? Year 400, 800, 1200, 1600 and year 2000. Which also means that the year 1700, 1800, 1900, which were century years, but as they are not divisible by 400, hence these years were non-leap years or ordinary years. Whereas 2000 is a leap year because 2000 is a number which is divisible by 400. So generally there is a myth amongst people. They say that a leap year occurs every 4 years. Well, it is true to a particular extent if we are talking about non-century years. But once we go from one century to the other century, then you must know that the century year in between, if at all it is divisible by 400, only and only then it is a leap year. Now we know that there are 12 months in a calendar year. These years have different days. Those months which have 30 days in them are April, June, September, November, that is 4 in number. Those months which have 29 days in them is only 1, and that is February, and that too, if at all, it is a leap year. And those months which have 20 days in them is again 1, which is February, provided it is an ordinary year or a non-leap year. So out of these two, 1. So 7 months have 31 days, 4 months have 30 days, and 1 month has 28 or 29 days. Now, any month which has 31 days in it will have 3 odd days. Now, how do we get that? Now, what do you understand by the term odd days? Once again, divide a number by 7, take the remainder. The remainder is extra days which are odd days. So, if you divide 31 by 7, it goes by 28 and the remainder obtained is 3. That is why any month which has 31 days in it will have 3 odd days. Now similarly, if you divide 30 by 7, you get 2 as the remainder. It goes by 28. So any month which has 30 days in it will have 2 odd days. February in a leap year has 29 days, so divide by 7 goes by 28, so 1 odd day. And February in a non-leap year or in an ordinary year has 28 days, divide by 7, you get the remainder as 0, so 0 odd days. So once again, 31 days will have 3 odd days, 30 days will have 2 odd days, 29 will have 1 odd day, 28 will have 0 odd day. Now let's have a look at a question wherein I'm going to discuss type 1 with you. Now what is type 1? 2 dates of the same year and 1 weekday. Now the day of the week for the reference date is given. The day of the week for the question date is to be found out. What does it mean? Let's have a look at the question first. Now if 15th January 2015 was a Sunday, then 23rd November 2015 will fall on which day of the week? Now look here. You are given 2 dates. Which are those? 15th January and 23rd November. Of the same year, that is 2015. And 1 weekday is given to you. The other weekday for the date which has been asked you in the question is to be found out. So the day of the week for the reference date. Now this happens to be the reference date. You'd have to take this as a reference, as the base. And for this, the day of the week is already given to you. Then there is another date which is mentioned, and this is your question date. And you will have to find out the day of the week on which this date falls. That is what is asked. So a reference date and question date, 2 dates are given. And for reference date, the weekday is given, which is given here as Sunday. And for question date, you have to find out the day of the week. Now, simple way of finding out the answer to this question is you calculate the number of odd days from 15th January to 23rd November. If you calculate all the number of days and then divide by 7, it becomes very tedious. So what we will do is, For each of the months which lie in this particular duration, we will keep on calculating the odd days, and then finally we will add up all these odd days and then divide by 7 to get the final odd day. Now, one thing that you must know is that number of odd days obviously is always less than 7. Why? Because it is the remainder is always less than the divisor. Now let's have a look at these months which lie in this duration. We're starting with January, then Feb, March, April, May, June, July, August, September, October till November. November which date? 23rd. January from which date? 15th. Now how many days are there in the month of January? Well, there are 31 days in the month of January, from which we will subtract the reference date. Why? Because out of these two dates, 15th and 23rd, we will count only one. I'll give an example. How many days are there from today to tomorrow? Well, there is only one day. You won't count today separately and tomorrow separately. How many days are there from today to day after tomorrow? Well, there are 2 days. Tomorrow and day after. So you won't count today. So out of these 2 dates, we will not count the reference date and we will count the final date or the question date. So anyhow, 15th, we are not counting, which means from 1st January to 15th of January is a period which we will not consider. We will consider number of days in the month of January from 16th onwards, because from January we are moving towards November. So after 15th January, the next date towards November, if you go, will be 16th January, 17th January, 18th January and so on. Anyhow, you don't have to count them literally. Simple, there are 31 days in the month of January. Out of that, 15 days are gone because we are not counting up to 15th of January. We will start counting from 16th of January. So now, how many days are remaining? Well, 16 days are remaining. And 16 days means how many odd days? 2 odd days. What are odd days? Divide 16 by 7. Remainder is 2. Remainder, after dividing a number by 7, remainder is called odd days. Now, since 2015 is a non-leap year, or let us say an ordinary year, the month of February in this year will consist of 28 days, which means 0 odd days. March has 31 days in it, so 3 odd days. April has 30 days in it, so 2 odd days. Well, we remember, don't we? Any month which has 31 days in it will have 3 odd days. Any month which has 30 days in it will have 2 odd days. And similarly, any month which has 29 days in it, that is February in a leap year, will have 1 odd day. And any month which has 28 days in it, that is Feb, in a non-leap year or an ordinary year, will have 0 odd days. So again, 31 here gives you 3, 30 is 2, June, July 31, so 3, August 31, so 3, September 30, so 2, 31 days in October gives you 3 odd days. Now, you will only count till 23rd of November. You're not bothered about the period beyond 23rd, that is 24th to 30th of November. We don't need. We are counting only from 1st of November to 23rd of November. And we are not even doing that. We're talking about 23 days in the month of November. Now 23, if you divide by 7, goes by 21, it gives you 2 odd days. So now you have odd days for all the months which are included in this duration from 15th of January to 23rd of November of the year 2015. So let's add them up. Well, 2 plus 0 plus 3 is 5, 6, 7, 10, and 2, 12, 15, 18, 20, 23, 25. 25 odd days. Listen to me carefully. In the examination hall, there is something called exam pressure. So, when you resort to counting these numbers and adding them up, you might commit an error. So, this 25 might become 24 or 26. How can you prevent this particular mistake from happening? Now, the whole point here is that you are going to divide this 25 odd days again by 7. Goes by 21. So what you get is a 4 odd days. So ultimately you want to find out the extra days after dividing by 7. What is division? Division is continuous addition. So you added 7 3 times. 7 plus 7 14 plus 7 21. And you subtracted that from 25 to get 4 odd days. So the point I want to make here is that while adding up all these numbers together, you add them up only till 7 and keep on subtracting 7. Let's see how do we do that. 2 plus 0 plus 3 is 5 plus 2 is 7. Okay, so 7 gone. 3 plus 2 is 5 plus 3 is 8. So 7 gone. Remainder 1. From 8 we subtracted 7. We got 1. Now 1 plus 3 plus 3. Again you remove this because this is 7. So what is the remainder that you get now? 2 plus 2. That is 4. That's exactly what I'm talking about here. So this is faster as well as more accurate because I believe that adding up numbers till 7 is not a problem at all. Adding them up to 25 will also not be a problem. But the larger the calculation, the more the number of steps, more are your chances of committing an error and faltering. So do it in bit by bit. We have divided this sum here without actually adding up all the numbers. But at the end, these 4 odd days is what we require. So Sunday plus 4 odd days. 4 days ahead of Sunday. Monday, Tuesday, Wednesday, Thursday. So Thursday happens to be the 4th day from Sunday. So hence, this shall become the answer. Now here you would have been in a position to answer the question much faster had you known that in an ordinary year, the month of January and the month of October, they have the same calendar. So my point here is that if 15th January of 2015 was a Sunday, then 15th October of 2015 was also a Sunday. See, you saved so much of time by not calculating from January to October. You directly jumped on to October. Now from 15th October 2015, we will find out till 23rd November 2015. See, now the length of the question has decreased here. It is not from January to November. Now it is from October to November. How? Because we know that in an ordinary year, January and October, they have the same calendar. So let's see here. October, November. 15th of October till 23rd of November. So 15 days in October gone. October has 31 days in it. So 31 minus this 15 will give us 16. 16 again means 2 odd days. 23rd November till 23rd we will count. So 23 divided by 7, again we get 2 odd days. And hence proved 2 plus 2 is 4 odd days. So once again we are getting 4 odd days here, as we got through other processes as well. But this obviously is much more shorter. So you should know both the methods. So this is the long method, let us say, and this is your shortcut, which I want you to memorize. And that is, in an ordinary year, January and October, they have the same calendar. So in a question, if at all you're given a question date which is in October or beyond October, let us say November, December, and your reference date is January, then the question is not from January to November, it is from October to November. So this is where you save time, and shorter the process, lesser are your chances of committing an error also. So your accuracy also increases here, just by remembering one simple concept that in an ordinary year or in a non-leap year, the months of January and October, they have the same calendar. Now let's have a look at another question of similar type. If 15th March was a Sunday, then 23rd November of the same year will be what day of the week? Let me give you 4 choices for this. Let us say choice A is Sunday, choice B is Monday, choice C is Tuesday, and choice D is can't say. What would be your answer? Well, is the year given to you, whether it is a leap year or a non-leap year? It is not given. So this 15th March could belong to an ordinary year. This 15th March could belong to a leap year. Does it make any difference to the answer? Well, you will feel, yes, it does. And that is why most of you would answer this question as can't say. That is incorrect. See, which is that month where the difference between an ordinary year and a leap year is exhibited? It is only because of the leap day. Which is the leap day? 29th February. Now 15th March is a date which is beyond 29th February. So as to say, so from 1st March to 31st December, the number of odd days will remain the same for leap year and for non-leap year. There is no difference. But from January to December, obviously, the story will change. From February to December, story will change. Why? Because February is included in this duration. From March to November, the February month is not included. So from March to November, the number of odd days will be the same, be it the March of a leap year or a non-leap year. So let us do the calculation here. So we begin with March here. Date is, reference date here is 15th March. That is not to be included. Now March here has 31 days in it, out of which we will subtract these 15 days. We get 16 days left over, and 16 is equivalent to 2 odd days. Goes by 14. April, 30 days, so 2 odd days. May, 31 days, so 3 odd days. June, 30 days, so 2 odd days. July, 31 days, so 3 odd days. August, 31 days and 3 odd days. September, 30 days and 2 odd days. October, 31 days and 3 odd days. November 23rd, again 2 odd days. Why? 23 minus 21 will give us 2 as a remainder. So what do? You keep on cancelling 7 at a time. So 2 plus 2 plus 3 is gone here. Again, 2 plus 3 plus 2 is gone here because that amounts to 7. So this is 7, this is 7. So these are subtracted. Now 2 plus 3 plus 3 is 8. Now 8 minus 7 again should give you 1. So there is 1 odd day for the said period. If you would have added this up, you would have got 22 odd days, and 22 also if you divide by 7, the remainder obtained will be 1. Alright, and from Sunday, 1 day ahead is Monday. That happens to be your answer. Now this seems long. Obviously it is. But if you remember that in an ordinary year, or let us say a non-leap year, the months of March and November, they have the same calendar. Obviously up to 30th day. Because November has 30 days and March has 31 days. So from 1st to 30th of March will have the same calendar as 1st to 30th of November. So if you remember this, the story becomes very simple. Now let us see how. Now 15th March is given to you as a Sunday. Now if 15th March is a Sunday, because we learned the concept that March and November, they have the same calendar, it means 15th November will also be a Sunday. Now from 15th November to 23rd November, because that is what is asked to us in this question, right? So 15 to 23, there are going to be 8 days, isn't it? So 23 minus 15. So 8 will mean 1 day extra. So from Sunday, you move ahead by 1 day to get Monday as your answer. That is given to us in choice B. So definitely can't say is not our answer. So you take care, and this is where you can save time and you can improve your accuracy. So till now we have learned 2 fundamentals. Which are those? In an ordinary year, the months of January and October, they have the same calendar. And in an ordinary year, the months of March and November will have the same calendar, obviously for 30 days, because November has 30 days. So in an ordinary year, which is a non-leap year and a leap year, then the months of March and November have the same calendar. Now, knowing such concepts would definitely shorten the length of the question. So these may be termed as shortcuts. Let's have a look at another question here. If 15th February of 2012 was a Sunday, then which day of the week fell on 15th August of 2012? Again, year happens to be the same. Two dates. This is reference date and this is question date. And this is your reference day's weekday. That is given to you. That is Sunday. So again, we will adopt our process, and that is the month of February here has how many days? Well, 2012. Now 2012, the last two digits form the number 12. So it is divisible by 4. That means this is a leap year. A leap year would mean that February has 29 days. So 29 days in February, out of which 15 days are gone, remaining 14 days. 14 days, 14 is a multiple of 7, so we will get 0 odd days. Again, March, so 31 days, so 3 odd days. April 30, so 2 odd days. May 31, so 3 odd days. June 30, so 2 odd days. July 31, so 3 odd days. August only till 15, and 15, if you divide this by 7, goes by 14, and remainder obtained is 1 odd day. Once again, we will adopt the process. We will not add up these figures. Now, surely you find 2, 3, 2. 2 plus 3 plus 2 is 7. And then 3 plus 3 plus 1 is also 7. So you should get 0 odd days here. If you add them, you will get 14 odd days, which is again equivalent to nothing but 0 odd days. And Sunday plus 0 odd day means same day, Sunday. Now, once again, you won't have to perform calculations. If at all, you would have known this, that in a leap year, the month of February has the same calendar as the month of August. Obviously, this has 29 days and this has 31 days. So, same calendar for first 29 days. Obviously, the lesser of the two. But it goes without saying that the months of February and August in a leap year, they have the same calendar. From the 1st of February to the 29th of February, we'll have the same calendar as from 1st of August to 29th of August. So once again, this is an important concept. So you don't have to perform any calculation. So 15th February of 2012, which is a leap year, is a Sunday. So 15th August also of the same year is going to be a Sunday. That's it. No calculation required. Which also means that in a leap year, if 25th of February is a Friday, then in the same leap year, 25th of August will also be a Friday. No calculation required. Directly you get the answer. So just 2 to 5 seconds is what you will take to answer this question. Okay, let's have a look at another question here. If 15th May was a Sunday, then which day of the week will fall on 26th January of the next year? Again, it is not given to you whether this year or the next year happens to be a leap year or not. We don't need that. When we are talking about May, the month of May is beyond February. Again, from the month of May to the January of next year, we will not be able to find the month of February anywhere. So hence, we will do our calculations irrespective of the fact whether we know or do not know the type of year which is given here. So once again, it's a month of May, which has 31 days in it. And we subtract the reference date, the starting date. We get 16 days remaining. And 16 days means 2 odd days. Now June, 30 days, so 2 odd days. July, 31 days, so 3 odd days. August 31, so 3 odd days. September 30, so 2 odd days. October 31, so 3 odd days. November 30, so 2 odd days. December 31, 3 odd days. And January till 26th. So if we divide 26 by 7, we will delete 21. So subtracting 21 would mean 5 odd days. Once again, we will use the same principle of calculating the final odd days by adding up these numbers till 7 and removing them. 2 plus 2 plus 3 is 7, so removed. Again, 2 plus 3 plus 2 is 7, so removed. Now 5 plus 3 is 8, which means 1 odd day, and 3 here. So 3 plus 1, total 4 odd days is what we should get. Or else you will add them up and you will find that these are 25 odd days. 25 when divided by 7 once again gives you 4 odd days. But this is much shorter and more accurate because division process is happening simultaneously when you are adding the numbers up to 7. So once again, Sunday plus 4 odd days would give you a Thursday. Do we have a shortcut here? Well, yes. Now for any year, be it a non-leap year or be it a leap year, the month of May will have the same calendar as next year's January. So they have the same calendar. So if this is known, then the length of the question again decreases. You must be wondering that how can I memorize so many concepts, so many things? There's so many months which are equal to some other month. I'll give you a table for that. It will be very easy for you to memorize and register properly into your mind. All right, let's reduce the length of the question now. 15th May of year X, let us say, is a Sunday. It means that 15th January of year X plus 1, that is next year after year X. This is also going to be a Sunday. Now 15th January to 26th of January of the year X plus 1. Now from 15 to 26, you know these are 11 days. Now 11 days would mean 4 odd days. So 4 days ahead of Sunday is Thursday. Well, this is the time period which was required to solve this question. So this becomes redundant. If you remember these concepts, they will save you time. And obviously, when you are hoping to become a civil servant and you're preparing for an examination of the stature of UPSC, you should not leave out anything, be complacent or lethargic that I cannot memorize so many things. All right, then take as many number of years as you want, because the problem is not that what you know or what you don't. The problem is your attitude. If you look at a particular thing and tell yourself, yes, this is easy, I can do it, that's when you will be able to absorb it. If you keep on telling yourself, no, this is difficult, I will not understand this, then in all probability you won't understand because you have closed all your doors to absorb that particular piece of knowledge. Anyhow, let's move forward. Well, this is what I wanted to give you. A non-leap year, or let us say an ordinary year, let us revise a bit, and a leap year. A non-leap year has 365 days and a leap year has 366 days. So we can say a leap year has 1 day more or extra as compared to a non-leap year. And this 1 day is 29th of February, as we know, which is also known as leap day. And in a non-leap year, January and October have the same calendar. In a leap year, please remember January, April and July, although I have not given you a question pertaining to that, but then you must memorize this, that Jan, April and July in a leap year have the same calendar. In a non-leap year, February, March and November will have the same calendar, obviously for 29 days. That's what I mean here. Obviously for 28 days here. And in a leap year, February and August will have the same calendar. So February here will have 29 days. Obviously for first 29 days, they will have the same calendar. Now this is all that actually memorize, and this is where we have a differentiation, because the months which are involved here are January and February. Now beyond February, I told you that from 1st March to 31st of December, be it a leap year or be it a non-leap year, the number of days will be exactly the same. And for that, the months which have the same calendar, the pairs are given to you as under March, November, April, July, May and next year's January. This is a question that we did just now. And then September and December. So you can memorize this very well, you can sing it like a song. March, November, April, July, May next Jan, September, December, March, November, April, July, May next Jan, September, December. Likewise. As it is, you see here, March and November, they have the same calendar. So similarly here, April and July, the months beyond February, they have the same calendar as per this table. So this table is going to be very useful. Just write it down 5 to 6 times or maybe more. But make sure that you register this properly into your mind. This will save time as well as improve upon your accuracy level. Now, the next type. The type 2 here, 2 dates belonging to different years and 1 weekday? Well, if you have observed, in the previous questions, there were 2 dates, reference date and question date, and both belong to the same year. January 2015, so November 2015, what day? March, then same year's November. Then February 2012, 15th February 2012, then 15th August 2012. But what would you do if there are 2 dates given to you? One is reference date, the other is question date. And you are asked to find out the day of the week on which the question date falls. And both these dates which are given to you, they belong to different years. Then what do? Well, you solve. So in this question, if 15th May of 1996 was a Sunday, then which day of the week fell on 26th October of 2020? So 1996 to 2020. How many years are these? 24 years, right? So the steps which are to be followed should be like this. First, 15th May of 1996 is given to you as a Sunday. From 15th May 1996 to 15th May 2020, let us say, if you find out, then from 15th May 2020 to 26th October of 2020, it will become very simple for you, because this portion will become type 1. That is when both of the dates belong to the same year. So this is the question for us. After that, this is the only addition actually to the previous type that we learned. What was the previous type? Both the dates belonging to same year. So find out 15th May 2020, which day of the week, and then after that apply type 1. Now, how do you do that? Now 1996 to 2020, number of years is 24. So how many leap years are going to be in these 24 years? Well, offhand, maybe I can hear you. You would say there are 6 leap years. How do you know? Because a leap year occurs every 4 years. No, I told you before, that is not the scenario. All right, let me give you an example here. 2007 to 2013. Well, how many years are these? These are 6 years. Now, 2009 to 2015. How many years are these? 6 years. But in the period 2009 to 2015, there is only one leap year, which is that 2012. This is the only leap year. So, here, if you divide this by 4, fine, I agree, you get 1. So, leap year here is going to be 1. But in the period 1, which is 2012. But in the period 2007 to 2013, there are 2 leap years. First, 2008, and the other one, 2012. So the number of leap years here is 2. Which are those? 2008 and 2012. Now you can see the number of years are the same. That is 6 in both the cases, in both the durations. But the number of leap years are not the same. So if you divide 6 by 4, you will get the quotient as 1, as you are getting in this case. Doesn't mean that it is 1 year. So you need to know the starting and the ending year. And for that, you should always start from the first leap year. So let's take another example here. 1943 to 1965. Well, as such, there are 22 years in it. Then how many leap years? Well, if you divide 22 by 4, 4 5s are 20. So there should be 5 leap years. But the leap years here are 6. Which ones? 44, 48, 52, 56, 60, 64. See, 1, 2, 3, 4, 5 and 6. So there are 6 leap years here. So how do you find out the number of odd days for these given years? That is the question. Well, you will have to find out the number of leap years for this duration. And how do you find out the leap years for this duration? Well, always count from the first leap year. So, in this particular duration of 22 years, if I want to know the number of odd days, we will add the number of leap years back to the number of years. So the number of years here are 22 and the number of leap years we will have to find out. Well, manually we found out that there are 6. But in actual, how you could have found out? Well, 1943 after that, which is the first leap year. See, the first leap year is 1944. So this is one leap year. Now, remaining number of years are how many? Remaining years, that is from 1944 to 1965. Well, that is 23. Now, this if you divide by 4, you will get 5 more leap years. So now in total we have 6 leap years. Now see, similarly here, 2007, 2013. First leap year is 2008. So you found out your first leap year. From first leap year to the final year. First leap year is 2008, final year is 2013. So 2008 to 2013. The number of years are 5, which when divided by 4 give you 1 more leap year, and that is how we got 2 leap years here. Now in these cases, you must observe that the number of years in total are 6 in these 2 cases, 22 in this case, where these numbers are not divisible by 4. But if at all the number of years for a particular duration is a multiple of 4, then directly you can divide by 4. So 24 here is divisible by 4. That is why you are dividing 24 by 6. If these would have been 22 years or 26 years, then we would have adopted this fundamental as I have discussed with you. That is, take out the first leap year and then divide the remaining years by 4 to get the remaining leap years. Add 1, that is first leap year. You will get the total number of years. We will solve a question of the same degree here. Anyhow, so these 24 years, you want to find out odd days. How many odd days are there? So in a particular period of years, if you want to find out odd days, first find out the leap years and add those leap years back to the number of years. Now by that, what do I mean? When you divide 24 by 4, because 24 is divisible by 4, we are dividing it by 4. Otherwise, we will follow this procedure as I have explained. So in this, we have 6 leap years. So the total number of odd days in this period must have been 30. Now why did I do that? Well, it's quite simple. These 24 years would consist of leap years and non-leap years. Just now we found out that there are 6 leap years and remaining 18 must be non-leap year. Now you know that in every non-leap year there is 1 odd day. In every leap year there are 2 odd days, 2 days extra. So 18 into 1 is 18 plus 6 into 2 is 12. You get a 30. Now this happens to be a long method. Shortcut, if you directly add the number of leap years back to the given number of years, you would get the total number of odd days. And how? Well, imagine all these 24 years are non-leap years. So for every non-leap year, you have 1 odd day. So 24 odd days. Plus, you have 6 leap years and a leap year has 1 day extra as compared to a non-leap year. So that is where we are getting 6 extra days. So 24 plus this 6 gives us 30 odd days. Anyhow, now 30 odd days is not the odd days that we want, isn't it? So because the number of odd days will always be less than 7. If the number of odd days is more than 7, please divide it again by 7 and get the remainder, which will always be lesser than the divisor, which is 7 here. So goes by 28, what we get is 2 odd days. So from Sunday, you go 2 days forward. So we get a Tuesday. So now your question is reduced to the first time. 15th May 2020 is a Tuesday. Then 26th October 2020 is what day? For which we apply the very method that we had learned here. 15th May, then we have June, 30 days, July, 31 days, August, 31 days, September, 30 days, October up to 26th October. So May is a month which has 31 days in it. So first 15 days gone, 16 days left, which means 2 odd days. June, 2 odd days. July, 3 odd days. 2 plus 2 plus 3 is 7. Removed. August, 3 odd days. September, 2 odd days. October, 26 minus 21, we should get 5. So 5 odd days till October 26th. So 5 plus 2 goes away. We are left with 3. So from Tuesday, you go 3 days forward. That is Wednesday, Thursday, Friday. So this is what we get. Now, mind you, 15th May 1996 in actual by calendar may not be a Sunday. This is just a reference date which has been created. It may have been a Monday, Tuesday, Wednesday, Thursday, Friday, Saturday maybe. But when you're finding out the answer to the question, you have to believe that 15th May 1996 was a Sunday, even if it wasn't in actual. It is just for the sake of solving the question. So any weekday could be given to you. It need not be the actual one as per the original calendar. Now let us solve another question here. If 12th September 1970 was a Saturday, then which day of the week fell on 2nd August 2018? So the question here is 12th September 1970 was a Saturday. So we will go up to here, 12th September 2018, find out for this. And from 12th September 2018, we will go in reverse direction and find out for 2nd August of 2018. How to do that? Let's have a look. Now, how many years are there from 12th September 1970 to 2018? Well, 30 plus 18, that is 48 years. So, the number of odd days, how do you find out? Well, to the number of years, you add back the number of leap years, which we find here to be 12. Why? Because 48 is a number which is divisible by 4. If the number of years is divisible by 4, then divided by 4 to get the number of leap years. But if it all, this would have been 42 or 46, which is a number not divisible by 4, in that case, the process is going to be different, which I am going to discuss in the next question. Anyhow, 48 plus 12, we should get 60 odd days. Now 60, again, we will divide by 7 because this is greater than 7. So goes by 56. We are left with 4 odd days. So from Saturday, we will go 4 days forward. Sunday, Monday, Tuesday, Wednesday. So we get a Wednesday here. Now our question is reduced to this much. That is 12 September 2018 is a Wednesday. Then 2nd August 2018 is what day of the week? Now why should we go backwards? We never go backwards. We always go forward, right? So we won't go from September to October. Let's do it the normal way. That is August to September. 2nd August to 12th September. Now the month of August has 31 days in it. So from that you will subtract 2 days. That is the reference date. You get 29 days. Now 29 days would mean 1 odd day. September 12th. So when you divide 12 by 7, goes by 7. Remainder you get is 5. So in total we have, so 1 plus 5 is 6 odd days. Now please remember that these 6 odd days now we have to take in the reverse order. So that, why? Because from September we have to go in the backward direction to August. So from Wednesday, either you go 6 days backward or you go 1 day forward. Obviously 1 day forward is better. So your answer here should be Thursday. Now let's have a look at another question. You'll get more clarity. If 29th July 2018 was a Sunday, then which day of the week fell on 11th June 1975? Alright. So 29th July of 2018 was a Sunday. So first you find the day of the week that fell on 29th July of 1975. Alright, now from 2018 we are going in the backward direction. We never go in the backward direction, do we? Instead of going in the backward direction, what we will do is we will move in the forward direction. Alright, so we will not take this. We will start from the 11th June 1975. Assume, now Sunday is already given to you here, so apart from Sunday, assume any day of the week. Alright, so let this be a Friday. If 11th June 1975 is a Friday, we will do it by comparison. Now you will get something for 29th July. As per our assumption that 11th June 1975 is a Friday, 29th July 2018 will work out to be a different day other than Sunday, maybe. Then we will see how many days of difference is there and we will find the answer. How? So 11th June 1975 is a Friday. We have assumed. So according to that, 11th June 2018, because first I need to find out the number of years. We will find out for 11th June 2018 what was the day of the week. And then accordingly for 29th July of 2018, we will find out the day of the week. So first, let's do this bit. Now 1975 to 2018, how many years are these? Well, 1975 plus 25 is 2000. So 25 years there. And 2018, another 18 years. So 25 plus 18 is 43 years. So we get a difference of 43 years. Mind you, 43 is not divisible by 4. So in such a case, what do? Well, in such a case, you will always find out the first leap year in the given duration. Which is going to be the first leap year in the given duration? Well, it's going to be 1976. 75 is not a leap year. 76, last two digits form the number 76, which is divisible by 4. So this happened to be your first leap year. Now from 1976 to 2018, that is for the remaining years. How many years are remaining here? Well, we just came 1 year ahead, isn't it so? So these are 42 years. This 42 we will divide by 4 so that we get 10 more years here. So 1 plus 10, this particular period has 11 leap years in total. So what do you do now? The number of years which are given to you, you add the number of leap years back to this to get the actual odd number of days for this period. Now if you divide this by 7, goes by 49. So remainder here should be 5. So 5 days ahead of Friday is same as 2 days before Friday, which is going to be a Wednesday. Now our question here gets shortened the very first time. That is 11 June 2018 is a Wednesday. So 29th July 2018 is what day? Although it is given as Sunday, but as per this assumption, let us find out 29th July 2018 is what day? So it's all about finding out the number of odd days in between. So you have June and then you have July. June 11th, July till 29th. Now the month of June has 30 days in it, out of which we will subtract these 11 days so that we are left with 19 days. Now this 19 when divided by 7, it gives us 5 as the remainder. Now similarly, July 29th, so 29 days in July, when you divide this by 7, goes by 28 to give you 1 as a remainder. So in total, you have 6 odd days. Now from Wednesday, you go either 6 days ahead or 1 day before, and that is Tuesday will be the day that you find on 29th July 2018. Now see, 29th July 2018, 11th June 1975. Now as per this assumption, when your answer here for 29th July 2018 came out to be Tuesday, in that case 11th June 1975 was Friday, correct? Now what is the relation here? Tuesday, how many days is Friday ahead of Tuesday? Wednesday, Thursday, Friday. That is, whatever is the day of the week which falls on 29th July 2018, if you add 3 to it, then you are able to get the day of the week that falls on 11th June 1975. So when 29th July 2018 is a Tuesday, then 11th June 1975 is 3 days ahead, that is Friday. And if at all this is a Sunday, as is asked to you in the question, then you will go 3 days ahead of that. Monday, Tuesday, Wednesday. This should be a Wednesday. So hence, 11th June 1975 works out to be a Wednesday. The given question, that is 29th July 2018, is a Sunday. So this is how, when you have to go back in time from 2018, you're going back towards 1975. You don't go back. You just simply go in the forward direction by assumption. So assume any day of the week for 11 June 1975. Accordingly, you will get a day. Accordingly, you will get a weekday for 29 July 2018. Compare that day with the original given to you in the question and see how many days of difference is there. Apply it like we did here to get your answer.